All right, hello. We're gonna jump right in. I'm gonna try to knock this lesson out quickly. Today we're gonna be talking about the equations of lines, and you're saying immediately right off the bat, like, didn't we do that in Algebra 1? Absolutely, you did. You hit probably the big three: the standard form of a line, the slope-intercept form of the line, and a point-slope form. All right, probably did all three of them, and there was a lot going on. All three of those have a good purpose for them. In geometry, we still need to talk about equations of lines, but we're gonna narrow it down to the most important type, and that's slope-intercept form. All right, that's your classic y equals mx plus b that some of your parents and guardians still remember to this very day if you threw that phrase out to them. So we're going to just focus on that one. But before we get into that, one of the main ingredients of slope-intercept is obviously the slope. So let's start off by talking about slope. Slope is simply the steepness or slant of a line. All right. Lines usually, do something like this or whatever. So this just measures what that slope is, or that slant. We use the letter M. Mathematicians still argue to this day why we use the letter M. Probably, to me, the best, makes the most sense is M for mountain, because, steepness, slope, all that kind of stuff. But, I don't know. People still argue about it. So, the slope, M, is literally the change in the y, or vertical direction, over the change in the x, which is the horizontal direction. And some people have even simplified it all the way down to slope is simply the rise over the run. All right? So take a few seconds, copy that down. I'm going to pretend like you did and you paused, and we're going to move on and learn. Okay, got something super important here. Look at this. Big gold asterisk. And this formula is double boxed in, so that's important. And it says, mathematically, when you have 2 points, an x1, y1, and an x2, y2, you can find the slope by doing this. Taking the second y minus the first y over the second x minus the first x. When you do that, you have the slope. There's another way to do the slope if you have a graph, which we seem to have over here. So I'll show you the mathematical way, because it works if you don't have a graph, if you have, as long as you have 2 points. And then I'll show you how you can chickadee check yourself if you have an actual graph. So in class today, I left these points blank and made my students figure them out just to speed things up. We'll just go ahead and figure them out together. So this point's over here. So his address or his coordinates would be left 1, down 2, and mathematically left 1, down 2 would be negative 1, negative 2, right? Left 1, down 2. Now, the point over here on the right is right 3, up 3. So that would just be 3, 3. All right, so there's the coordinates. We're going to put them into the magical formula. Again, the whole idea of, well, who's the x1 and who's the x2? Doesn't really matter, but I just strongly encourage you, always go from left to right. That's how we do most things in math. So that's what I'm going to do. So this point over here on the left, he's going to be my x1 and my y1. And this one over here would be, of course, my x2 and my y2. All right, so I'll put them in this magic formula. And the magic formula says, of course, take the second y minus the first y. So I would say 3 minus double negative. It's a negative 2. So we got right off the bat, we start off with a double negative. Always be mindful of those because they change the problem around a little bit. And then down in the basement, we have the second x minus the first x. So we have 3 minus a double negative again, minus our negative 1. So upstairs we got a double negative, which turns into plus plus. And downstairs we have a double negative, which turns into plus plus. So your final answer, if you did this one ahead of time, I hope you got 3 plus 2, which is 5, over 3 plus 1 is 4. 5/4 is your slope. Mr. Metcalf, my teacher told me that's an improper fraction. Your top should never be bigger than your bottom. Most of the time in mathematics, that's correct, and you would want to fix that by making it into a mixed number. Slope is one of those rare examples where we don't normally take an improper fraction and turn it into a mixed number. You want your slope to be a fraction, is what I'm trying to say. So leave that. Now, if the fraction will reduce, like say you have 10/8, yes, reduce that to 5/4. But having an improper fraction is okay as long as it's down to its lowest terms. All right. So what does that mean? Well, you can check your answer, because what this is telling you is that the line is going up 5 units for every 4 units it goes over. So the rise is 5 while the run is 4, and let's see if that's true. So I start, like I said, always start on the left, go to the right. So this is telling me to rise 5, run 4, and let's see if that works. 1, 2, 3, 4, 5. 1, 2, 3, 4, pow. It sure does. So that is absolutely right. That's the slope, 5/4. Pretty easy problem, right? And that way with the graph is how you would check it. You can literally put your pencil tip on the left-hand point, count how many you have to go up or down. Sometimes you have to go down, and then over, and you'll have your slope. And so let's try another one. Okay, we got 3 examples here. 2 of them are kind of weird. We got the perfect up and down line and the perfect side to side line. So those are, we call them special lines. We'll talk about that in a minute. And then we got a regular one. Since we have a graph and we're trying to save time, you could find the coordinates of these 2 points and do the math version. But when a graph is provided, make your life easy. Do the counting style. So now this one, when you look at it from left to right, it's going down. So this one should have a negative slope. When the line goes down, that indicates a negative slope. All right, so let's see if it does. So I've started up here on the left, and I'm going to go to the right. And to go from left to right, I literally have to go down, which in math is negative. So I'm going down 1, 2, 3, 4, 5, 6. So I went down 6. And then I go over 1, 2, 3. So my slope would be -6/3. And some of you are saying, hey, that'll reduce. You just told us we should reduce it. So yes, let's do that. -6 and 3 both will reduce down by 3s. So what that means is 3 goes into -6 negative twice, and 3 goes into 3 once. So your best answer for slope would be -2/1. Now some of y'all are saying, can I just make that -2? Absolutely. But you normally want your slope to be a fraction, because it's telling you the 2 directions you need to go to get from one point on that line to the other point. So I would leave it as -2/1, but if you put -2, you're absolutely correct. Absolutely. Okay, now let's see if y'all can remember back to Algebra 1, because I know your teacher had to talk about these 2 guys, the horizontal line and the vertical line. They're a little bit different. That's why we call them special lines. And I got a little cheat sheet coming up here in a minute that really takes care of all the cool stuff about special lines. But we'll start off with the horizontal one first. So at this point in the class, I would stop and I'd let the students, try to remember way back to Algebra 1 and what their teacher said about the slope of a horizontal line. And most of the classes came up with it after prying a little bit. I got them to let me know. And the way I like to think of it is, imagine if you were riding a bike on that line. And you would be like, oh, wow, it's not going up, it's not going down. So is the slope 0? Absolutely. It has 0 slope. All right. Now don't say no slope, because some teachers, no slope means something else. So don't say no slope, say 0 slope. Okay. Because it does. If you try to do the rise, right, there is no rise. It stays on the same horizontal spot. So the rise technically would be 0. And in this instance, the run, I do have 2 points labeled. The run would be 1, 2, 3, 4, 5, 6, 7. So 0 over 7, you all know, is 0. So yeah, the slope is 0. All right, let's look at this guy. Now this one's a little more interesting. He goes straight up and down. So is his slope infinity? Because it like goes forever. Well, I labeled 2 points just to point out how you get the answer we're going to get. So, and again, some students in class today knew what it was. All right, so I put a point right here and a point right there. So if you wanted to do the rise over run thing, here's what you would do. You say, okay, I don't know who's left and who's right, so I'm just going to start right here, and I'm going to go up 1, 2, 3, 4, 5. And if you started up here and went down, of course you would have got -5. All right, so then what's your run? Well, the run, there is no run. The run is 0. So whether you went up or whether you went down, you're going to get -5 over 0 or 5 over 0. And guess what happens when you do that on your calculator? If you did 5 divided by 0 on your calculator, you would not get 0. Unless you have a really weird calculator. If you did 5 divided by 0 or -5 divided by 0, you would get an error. Some fancy calculators will actually write UND for the correct answer, undefined. All right? The slope of a vertical line is undefined. All right? And maybe that sounds familiar from Algebra 1. I hope it does, because I know your Algebra 1 teacher taught you that for sure. You may have forgotten it because it was a long time ago, but I know they taught it. All right, here we go. Moving on. And here's a little cheat sheet just to show you the 4 basic types of slope we have. And again, notice how all the bicycles are trying to go from left to right. All right, that's how you read a line, like a sentence on a page. You start on the left and go to the right. So all these bicycles are trying to go from left to right. And from left to right on this one, obviously the bicycle is going up, so that would be a positive slope. On this one, from left to right, the bicycle is going down, so that would be a negative slope. And here's the guy, remember, he's riding his bike on the flat surface. So he's saying, oh, wow, this is easy. It's not going up or down, so the slope is 0. And then here, and this is how I still remember this to this very day, the difference between 0 slope and undefined slope is, imagine trying to ride your bicycle up the side of a building. I mean, Spider-Man couldn't do it. Tony Hawk couldn't do it. Nobody could do it. It would be impossible, all right? But we don't say impossible in mathematics. We say it's undefined, all right? So there's your little cheat sheet for the 4 different types of slope. You have positive, negative, 0, or undefined. All right, moving right along, man. We're flying through this lesson. Good job today. All right. Okay, now we're getting into the meat of the lesson, the actual equations of a line. Like I said, I named all 3 that you probably did last year. We're going to stick with slope-intercept form this year. That's the classic y equals mx plus b. That's a b, as in Bravo, not 6. And b represents the y-intercept. That's a fancy way of saying where the line crosses the y-axis. So you got your y-axis, you got your x-axis. This number literally tells you where the line hits the y-axis. All right. Now, the key thing about slope-intercept form is the y needs to be over here all by himself. You got to get everybody else on the other side. The x's, the regular numbers, y's got to be by himself. Can't have a fraction on him. Can't have any kind of whole number on it other than 1. You know, 1's okay. But besides that, everybody else has got to be on the other side. So if you have those 2 ingredients, the slope and the y-intercept, all you have to do is just put the slope right here, usually a fraction, doesn't have to be, and then you put the y-intercept right here, usually an integer. But again, it doesn't have to be. It probably will be in most of the problems today, but it doesn't have to be. Okay, so in this one, you'll just see how easy it is. Today in the lesson, some kids were afraid, they're like, this is too easy. It can't be what I think it is, but it is. All you got to do, they gave you the slope is -2/5, the y-intercept is 6. You literally just take these numbers, boop, boop, and put them right there. And that's it. That's all you have to do. So are you telling me, Mr. Metcalf, the answer to this first one, the equation would be, yes, it would be y equals the slope, negative 2/5 x plus b, which b in this problem is 6, and then you just drop the mic. You're done. That's all you have to do. But I thought we had to solve it, Mr. Metcalf. No, it just says write the equation. That's all you have to do. So now everybody can do this one. It's super easy now I've showed you how to do it. So pause it and do it real quick, and we'll see what you should have got. So if we follow the same format, we would say y equals, slope is negative 1x plus negative 3. All right, so that is totally correct. But on a multiple choice test, their answers are usually in simplest form, meaning they get rid of any unnecessary symbols or numbers, or they reduce fractions down. They don't usually leave anything unsimplified. So even though this answer is perfectly correct, you might not see it on a multiple choice test because there's not one, but there's two things in there that are really, as we say in the hood, extra. So do you know which two things I'm talking about? Well, one is the 1. You don't need to say negative 1x. You could actually just say negative x. So that's one thing right there that's not necessary. And then over here, you don't need to say plus negative 3. You could literally just say minus 3, and there's not really any way to simplify the y. So on a multiple choice test, these two answers are the same, but this will probably be the one that they have. Can y'all see that's kind of low on the screen? Yeah, you can see it. So y equals negative x minus 3 means the exact same thing as this. Both correct. All right, moving on. Oh, man, we had fun on this one today in class. People got to come to the board, and then I cleaned off the things because of Rona. We cleaned after each usage. We got 4 things that need to be graphed. 3 of them are ready to go. He's ready to go. Look at that. You see your y equals mx plus b. Perfect format. These 2 guys down here are special lines. Those are easy if you remember the secret on how to do special lines. And this guy, he is actually, I think, he's kind of in point slope form, if I remember back to my Algebra 1. But again, we don't want to mess with that. If they're ever in the wrong format, let's just convert them to y equals mx plus b, and then we'll know what to do for sure from there. So we're going to do this one actually first and convert him. I'm going to pretend like you're pausing and you're trying to convert it already. A couple of things are going on. I'll just give you a hint before you hit pause. You got to get rid of this minus 3 because the y's got to be by itself. And then you got the distributive property over here. You'll probably want to deal with that so your numbers are all correct. So hit pause, try it yourself, and then let's go. All right, so I'm going to do the distributive property first. I'm going to do the negative 2 times the x, and I'm going to do this in purple. Okay, so negative 2 times x would be, I'm still not in purple. Okay, would be negative 2x, and then negative 2 times 3, that would be negative 6. And it still equals the y minus 3. All right, so I'm pretty close, but I still got to deal with this minus 3. So to get rid of him, I'm going to go plus 3, and then to be equal, I'm going to put a plus 3 over here. And that gets rid of him, and now the y is all by himself. So this guy's going to be ready to graph as soon as I finish doing this. So I got y equals negative 2x, and then the minus 6 and the positive 3, that's going to come out to be minus 3. So now we're in slope-intercept form, and we're ready to graph. So again, if you want to hit pause and try to graph it, you can. I'm going to jump right in. And the number on the end, remember, this is the y-intercept, or the b in y equals mx plus b. And I just tell my students, well, you all are my students too. I tell them B does not really stand for begin, but that's where you should begin your line. We're going to begin it at negative 3 on the y-axis, so that would be right, 1, 2, 3, that'd be right here, negative 3. And then the slope, now, it's not a fraction, but I think everybody knows how to make any number into a fraction. You can make any number in the universe into a fraction simply by putting it over 1. So negative 2, if I want it to be a fraction, and with slope I do, I just put it over 1. And now it's telling me, hey, go down 2, right 1. Not from the origin though, no, from the B point, the beginning point, all right? So I'm going to go down 2, right 1 from here. Down 2, right 1. And that's all you need. Technically, you only need 2 points to create a line. I had some kids today, got some good algebra teachers out there, because some kids today did a third point. And if you did a third point, keeping going this way, you would go off my little graph here. So they knew the other trick. Instead of going down 2, right 1, guess what they did? Yeah, you're right. They went up 2, left 1, and got another point. And you could keep doing that, and then you'd have yourself a nice little line. But this is probably good enough. So I'm going to do this right here. I'm going to draw my line. I'm not using my cheat tool this time, so I don't know how straight that's going to be. You always should put those arrowheads on there. And since I'm actually color coding my 4 different graphs, I don't have to write the equation for the graph on here because I'm color coding it. But technically, if you were putting more than one line on the same graph, you should put the name of the line on the graph or at the end of it or somewhere. But I'm color coding mine, so I'm okay. So I did the purple line, and there it is. Now I'm going to do this gold line. So he's ready to go, all right? He's in the y equals mx plus b format, and the b is positive 1. So I put a dot on positive 1 on the y-axis. I look at my slope. My slope is positive 2 over 3, so that's telling me to go up 2, right 3. So from here, I go up 1, 2, and I go right 1, 2, 3, which puts me there. And if I wanted to do that little trick, I could also go down 2 and left 3 to get another point. And let's try to draw as straight as possible. Put my arrowheads to show it goes forever, and there's the gold line right there. Look at that. Don't even have any scrap work under him because he's ready to go. I mean, he's in the right format. You may have to do this on some of your problems on your worksheet. Now, special lines. The first time we do a special line, it's always tricky because everybody has to remember, do I go this way or do I go that way? And it kind of is tricky because everybody in here knows, I hope, everybody knows that the y-axis is the one that goes up and down, so you would think this y line would also go up and down, but it doesn't, all right? Y lines actually go this way, and I'll show you why when we graph it. So most people, and it's in red, so let me switch over to red real quick. So this one is y equals positive 4. So I'm going to go up to positive 4 on the y-axis, and almost every student gets that part right. They say, okay, I'm going to go up here to 1, 2, 3, 4, and they put a point. And a couple of people put that point, and then they turned to hand me the marker back because they thought they were done. I'm like, no, remember, it's a line you're graphing. And then they started thinking, oh, they got a little confused. And they're like, okay, the y-axis is going up and down, so should this guy go up and down? And then they realized, wait a minute. This equation is actually saying y equals 4. That means y is always 4. It's not going to ever be something else. So if I start going down, I'm actually changing y from he's not 4 anymore. If I go down to here now, y is 3, he's 2, he's 1. So don't go down even though the y-axis goes down. Stay up here. Because guess what? Up here, y is always 4. All along that line, y is 4. Now the x is changing. Right now, y is 4 and x is 0. And now x is 1, and x is 2, and x is 3. But y is staying 4 the whole time, and that's what it's telling me. Y is always 4. And once you remember that, then the x one will be easy. You'll be like, okay, I know what to do now. All right? And so hopefully everybody's doing that. I'm going to switch over to blue. And this one says x equals negative 3. And you're just like, but Mr. Metcalf, that's not in slope-intercept form. Technically, you're right, because the y isn't by itself. But that's because he has no y. A special vertical line doesn't have a y in it at all. So it's going to be x by himself, and I come over to negative 3, 1, 2, 3, and for an x special line, it is vertical. So I just go straight up and down because this is where x is always negative 3. Boom! There you go. Man, I hope y'all are getting this. If you're not, get on a Google Meet sometime. I don't know if I think Mr. Crabtree already did the one for this week. So I don't know. We'll see if we're going to do one over the fall break. I might do one myself. Wouldn't that be fun? All right. Let's go on to the next screen. We're almost done, guys. Second to last screen. And yeah, I got to get moving, man. I got to get home. All right. So what I've done here is I made a little cheat sheet for special lines. It's got everything you need to know about special lines on here. So I'm going to put a red asterisk next to that. So I got the horizontal, and I even got a picture of horizontal. There he is. He's going side to side. His slope is always 0. His equation is always just going to be y equals some number. There won't be an x in it. If there's an x in it, it's not a horizontal line, all right? It's not a special line. If there's an x and a y, then it's not a special line. Special lines either have an x only or a y only. They don't have both, all right? So then I give you an example. Here's a good example of a horizontal line. Y equals -2. So let's just go ahead and show you what that would look like. Again, y equals -2. That means you come down to -2 on the y. Most people have that part. No big deal. But then they try to decide, do I go this way or do I go that way? Well, where y is -2 is all along here. That's where y is -2. Blam. All right. And then our vertical line, which I have in purple for some reason, so I'll switch over to purple. The vertical line, that's up and down. Remember, his slope is the one that's undefined, because if you tried to ride a bicycle up this, you couldn't do it. It's impossible. His equation is the weirdest of them all, because it doesn't even have a y at all. It's just an x equals some number, all right? And here's a good example, x equals 1. I'd come over to 1 on the x-axis. And then it's a vertical line, so I go straight up and down. And coincidentally, that's where x is always 1. He's not changing. He's always 1 right there. So, bam. Here's a nice little cheat sheet for special lines. Hopefully you keep that. We'll have our next test won't be until way after fall. Well, not way after, but way after fall break. So this is the last lesson before fall break. So better just go ahead and update you on that. I'll go ahead and click to the next screen so you can be writing it down while I explain that. So fall break, Miss Cook said, hey, go easy on yourself, meaning the teachers, and go easy on your students for this fall break. And so I'm listening to my boss as always, and I'm going to go easy on you also. Each Monday of the 2 weeks, I'm going to put an assignment up there, and the first Monday assignment will be like a review of the lesson we did the other day, 3-5. It'll be kind of a review of those concepts. So do that one, and then the following Monday or the second week of the break, there'll be another review sheet that'll be kind of like this equation to line stuff. All right. So that's all it's going to be. There's not going to be any new videos over fall break. Just 2 worksheets, 1 for each week. But do them. All right. That's 200 points. You know, each 100 points for the first one, 100 points for the second one. So it's 200 points, and we're early in the quarter, so 200 points make your grade swing high or low if you do or don't do them. So please do them. All right. Last thing we got on the agenda today is what if they give me the graph and then ask for the equation? All right. So we're kind of working backwards. All right. So write an equation of a line from a graph. Well, remember, you need 2 juicy ingredients. You need a slope, and you need you need a slope, and you need a y-intercept or the b. All right. So here we go. We look at this. I got a little area for scrap work. I'm not just going to jump in and do it. I'm going to find the slope, and then I'm going to find the y-intercept. So again, always read it from left to right. So I'm going to start here at this left point and go over here to this right point, and it's a drop. So my slope better be negative because this is going down, right? So it's going down 1, 2, 3. So -3, and then it's running 1, 2. So my slope is -3/2. So far, so good. Now, B, remember that represents where it hits the y-axis, and it's hitting the y-axis right about there. Now, I was kind of didn't do a perfect job on this one. It's hitting the y-axis somewhere between 2 and 3, so I'm going to call that about 2.5. All right. So you can do 2.5, or you can do 2.5, either one, they're the same thing. So now that I got the two juicy ingredients, here's how easy it is. Remember, we're just trying to do y equals mx plus b. I got my m and I got my b, so I'm ready to go. I just put them in the formula. So the equation would be y equals -3/2 x plus b, which in this case is this weird 2.5 deal. And that's it. You can put 2.5 if you want. Awesome. Pretty easy stuff, right? As long as you can pick out the slope and the intercept, you're good to go. So here we go. Last one. This is it. Screen 8. Yep, screen 8. We're out of here after we do this one. So again, I would pause it, I would try it, and then hit play again and see if you got the right answer. So welcome back. Let's see if you got the right answer. All right. So the slope, again, left to right. So this time left to right we're going up, so we better have a positive slope. So from this point to that point I have to go up 1, 2, and then I have to run 1, 2, 3, 4. So my slope is 2/4, but some of y'all are saying, hey, Mr. Metcalf, I'm not great at fractions maybe, but I know 2/4 will definitely reduce down, and you would be right. 2/4, I think most people know, reduces down to 1/2. If you didn't know that, you just try to find a number that they both have in common. They both have 2 in common, not Tutankhamun. Any Egyptian historians out there? Tutankhamun? Okay, so 2 goes into 2 once, and 2 goes into 4 twice. So yes, it reduces down to 1/2. And again, multiple choice answers are always reduced down to the lowest terms. So our slope we're going to use is going to be 1/2. Now the b, and last time I'm going to say it for today, the b represents where the line crosses the y-axis, and it crosses it right here. And that appears to be 1, 2 at 3. All right. So I got the 2 ingredients. I put them in the magic formula, and I'm done. So give you half a second to do that. You should have done this. Y equals mx, and my m is 1/2, x plus my b, which is 3. Nothing to simplify, no unnecessary characters. Technically, you know what? I'm going to show you this because it's the end and I got a few seconds. Some people would say, you know what, that 1 actually is not necessary, Mr. Metcalf. You could write this thing slightly different without the 1. I'll give you a few seconds to try that at home, but here's what you could do. I would probably leave it like this, but technically if you were trying to save ink for some reason, like there's an ink shortage in your area, and you don't want to, you want to save ink wherever possible, you could actually write this like this. You could say y equals, instead of saying 1/2 x, you guessed it, I bet, you could say x over, oh, that's an x, over 2 plus 3. Because there's a ghost 1 right there in front of that x, so you technically got your 1/2 x plus 3. I like this one, but that one is true as well, and it saves you a little bit of ink. All right, I'm done, man. Hope you all got that. So we learned how to write equations in slope-intercept form from a graph, from information. We learned how to figure out slope. And if you have any questions, just send me an email or a Google Classroom. But check Google Classroom because, like I said, this is it until that worksheet on Monday. Oh, there is a worksheet for this one too. Don't freak out and say, oh, I don't have to do anything till Monday. No, right after you watch this video, boom, there's going to be a worksheet right next to it. And then Monday, there'll be a worksheet for the first week of fall break. And then the following Monday, there'll be a worksheet for that second week. So until then, I'll see you. Hope you have a good fall break, and we'll see you in a couple weeks.